Hello everyone. So in this video we will see how to use Balun. Okay. So this is widely used in RFIC design and analog IC design. Okay. So this converts if you apply any unbalanced input, so it will provide a balanced equal and opposite output. Okay. So by definition, this terminal is differential. This one is common, and this one is output positive terminal, and this one is output negative terminal. Okay. So click this one and press Q. So this is from analog library, and name of this instance is ideal Balun. Okay. And this is from basic library, and name is no connection. And this one from analog library, name is vSine. So I have given 100 millivolt peak to peak and 1 kilohertz sinusoidal signal. Okay. So 100 millivolt peak to peak, 1 kilohertz sinusoidal signal. And this one is 800 millivolt. Okay. So name of this instance is VDC. This is also from analog library. And this one is 200 millivolt peak to peak sinusoidal 1 kilohertz signal. And this one 600 millivolt. Okay. So I have given different values so that we can validate our every possible combination. Okay. So after creating this schematic, go to the launch and click ADL. Then you will get this one. Okay. So here go to the edit or choose here from analysis. Okay. So I am doing transient analysis. I have given 2 millisecond. Okay. So you can give any time and click OK. And then run the simulation. Now it's completed. Now here click the wire and plot voltage transient. So here you can see 1.25. So DC is 1 volt, and on top of that 0.250 millivolt of sinusoidal signal. Okay, we will validate by calculation also and plot this one. And this one is DC is 0.2 volt, and peak to peak is like 350 millivolt. So now we will validate how this is working. Okay, so now let's calculate. So how the Balun works? So the out positive output voltage of Balun is Vc plus Vd by 2, and negative output terminal will be Vc minus Vd by 2. Okay. So we have applied at C terminal, we have applied 600 millivolt and 200 millivolt of sinusoidal signal. So this will be 600 millivolt plus 200 millivolt sin omega t. Okay, so this one is Vc. And at D terminal, what we applied? We applied 800 millivolt of DC plus 100 millivolt of sinusoidal signal. So we will get half of this. So how much this will be? So this is 400 millivolt and 600. So this will be 1 volt plus 50 millivolt sin omega t and 200. So this will be 250 millivolt sin omega t. Okay. So what will be the negative output terminal? This will be Vc minus Vd by 2. So this will be 600 millivolt plus 200 millivolt sin omega t, and here it will be minus. So 800 millivolt plus 100 millivolt sin omega t divided by 2. So how much this will be? So 400, 600. So this will be 200 millivolt and plus. So this 50 and 200. So this will be 150 millivolt sin omega t. Okay. So at positive terminal we will get 1 volt of DC and 2 millivolt of sinusoidal peak to peak signal. And at negative terminal we will get 200 millivolt of DC and 150 millivolt of sinusoidal. So what will be the peak value? Peak value will be 1.25 volt. Okay. And here peak value will be 350 millivolt. Now let's verify. So here 1.25 volt peak voltage will be, and here 350 millivolt. Now go to the simulation. I will check there. So here we can see that our peak to peak is here 1.25 volt. Okay, 1 volt of DC, and on top of the 250 millivolt of sinusoidal signal. Here 200 millivolt of DC and top of the 150 millivolt of sinusoidal signal. So peak value is 350 millivolt. Okay. So this is how you can verify by your own. So basically this terminal will be VC plus half of this. This terminal will be VC and plus minus half of this terminal. So we in our op-amp design we can like calculate individually verify. You can verify our theory like individual terminal, all the theory what they have given in Rajavi books or any other books. So we can individual gain or all thing you can verify your theory by converting these kinds of technique. Next thing you can do by your like connect one common DC source. Okay, so remove one and bias this only. Like I will remove this one and this one. Okay, and then connect directly this one. Check and save. So how much this is? This is 600 millivolt and this one is 100 millivolt peak to peak voltage. So what should be coming here? This should be coming 600 millivolt of common mode signal and 50 millivolt of peak to peak positive. And here 600 millivolt of DC signal and minus 50 millivolt peak to peak of sinusoidal signal. So let me run. So it's completed. Now let me this cancel. So here see 600 millivolt on top of the 50 millivolt. Okay, so this one positive plus 50 millivolt sinusoidal signal, and this one is 600 millivolt, and this one is minus 50 millivolt sinusoidal signal. So this is how we can convert a differential signal into two half equal and opposite uh, differential output. Okay, so I hope I was able to explain, and you can relate these things by theories. Okay, so if you feel any doubt or something, so please let me know. I'll try to explain or try to make another video. Okay, bye. Thank you.